Okay, I wanted to do one more with you guys, and the reason is that the other two sequences we did were geometric. This one is arithmetic. So, this guy and the warm-up that I did for you guys, these are geometric, which lead to these kind of rules that involve an exponent. My arithmetics will not have an exponent. Okay? Instead, they'll have multiplication in the explicit rule. Don't worry, don't go like, oh my God, what does that mean? I have to memorize it. Do not worry. We're gonna do this problem the way we did the other problems, and then you'll see it. It's gonna work itself out, okay? The logic will be there. So let's take a look at this pattern they've got. And I'm gonna again recopy it so we could do our n, our tiles, and then our pattern. So here we go. In figure 1, our number of tiles is 5. In figure 2, our number of tiles is 8. In figure 3, it's 11. And in figure 4, what are we doing? We're adding 3 every time. So it'll be 14. And in figure 5, it'll be 17. So just keep adding 3. So let's go create the pattern, okay? So for the first guy, it's just 5. For the second guy, it's 5 plus 3. For this guy, again, I'm going to copy the previous one down. 5 plus 3 plus another 3. In this one, it's 5 plus 3, the previous term, plus another 3. And now it's 5 plus 3, plus 3, plus 3. That's the previous term, plus another 3. Okay. Now let's go rewrite this to come up with the pattern. Okay, so this is where it's going to be a little different, because this is an arithmetic sequence and the operations are different. We're plussing here, we're adding here, where before we were multiplying. So obviously it's going to make a little difference, and you got to make sure to notice that difference, okay? So here I have 5 plus 3. 1, 2, 3, 4 times. Plus 3, 4 times. So that means I multiply it by 4. Okay? No exponent this time. That's what I meant here. No exponent this time. This time it's just multiplication. So 3 times 4. Okay, let's keep going. Here it's 5 plus 3. How many times? 1, 2, 3 times. Over here, I have 5 plus 3. How many times? 1, 2 times. Here, I have 5 plus 3. How many times? 1 time. And believe it or not, over here, I have 5 plus 3. How many times? 0. I don't have any 3s. So let's now that we've done this, remember before we said find the correlation, right? Find the correlation between n and the exponent. Well, now I want you to find the correlation between n and what you're multiplying over here. So let's go find this correlation. Over here, 0. Over here, it's 1. Over here, 1, but n is 2. When this is 2, n is 3. When n, let's go backwards. When n is 4, this is 3. When n is 5, this is 4. Every time, okay, this here, every time this here, I always do that with that highlighter. every time this is 1 less than n. It's always 1 less than n, okay? So remember, the two scenarios are, we're either going to put n in our rule, or we're going to put n minus 1 in our rule. We choose n for our rule when they are the same. And we choose n minus 1 in our rule when it's 1 less. And in this case, we are 1 less. So we are not going to use n this time. We're going to do this. So let's check out our rule. It's going to be 5 plus 3 times, we said 1 less is n minus 1. So n minus 1. That's it. All done. And just like the geometrics, we can see that we still get to see our first term, our common difference or constant difference, and then the n. So first term. So again, once you learn the pattern, you might jump straight to the formula. Just put your first term plus your constant difference. And then just figure out if it's going to be the same or 1 less. And then so you would either put n or n minus 1 right here. And that's it. Good luck, guys. Make sure you have your questions ready for me when I get back.